I was telling you, function is nothing but the solution what you are working for. Function is what? There is two things. People may get confused between the functional requirements and the requirements of the product. For example, if you have a pen, the pen's functional requirements is to write. Other requirements is the pen should be of the diameter of 10 mm. The length should be of 15 centimeters or so. These are all requirements for manufacturing the pen. But basically, what the pen function is, it has to write. So you need to understand for what function this product is being made. So the FMEA will. The objective of the FMEA is to identify the functions of the products or steps of a process, the associated potential failure, etc. Then, if at all failure comes, what will be the detection mechanism, and how to prioritize which one to take first. Then there is a foundation FMEA, in the sense people will be having some family of product, and you can have some foundation FMEA for that. Overall, or some FMEA you can do based on the model minor differences. You can fine tune your FMEA for the part number wise. That is the thing it is told here. Then what are all the cases you will be using this FMEA? Sorry. Case one is new design, new technology, or new process. Whenever you are going to do some new design, new technology, new process, you can apply FMEA. You have to apply FMEA. New application of the existing design. In the existing design or the process, if you wanted to apply new application, that time you have to do FMEA. And engineering changes, already there is a design, there is a process on which you wanted to do some engineering changes. Whenever you do some changes, no, it may influence some other defect. Sometimes you go for fever, the doctor will give you ulcer. Whenever you take some pill for fever, he may be giving some antibiotic. Antibiotic is acidic based, but if you don't take antacid along with that, you will get ulcer. So you are doing some change in your product. Whenever there is a change, there is a possibility of influencing some other defect also. So that also you have to do. Whenever that things happen, you have to do FMEA. When you are doing FMEA, you have to start with the project planning. Project planning, here we talk about 5 T's. 5 T's are intent. Here intent T is 1 T. Intent T is 1 T. Timing, team, task, tools. So first of all, intent is what? Objective. Lakshya. Kurikol. Intent is objective, Lakshya, Kurikol. Timing, you know that. Team. Who are all the team will be better for carrying out this particular project? For each team member, what are all the tasks to be given? There may be a tooling person. He need to be given some task on tool development related task. And there may be a quality person. He need to read the drawing and tell them what is really important here. If there are any concern area, he need to come out with that. Likewise, each and every process member should participate. Production, quality, maintenance. You have to bring the team member. Each team member should have the task. Then tools. Here the tool is what kind of analysis tool you will be using. There is something called YY analysis, 8D analysis. Likewise, what kind of tools, fault tree analysis. What kind of tools you will be using for analyzing a defect or a failure. Okay, so this is where intent is. Why are we doing this? When it is due, who needs to be done, what work needs to be done by them, how do we conduct the analysis. This is what it is. The 7-step approach goes like this. In one shot, I will give you a clean explanation of this. You will get the background. Based on the background, if I proceed further, you may be able to understand better. First step is whenever you start for a project, you have to plan what for this project is being done. As I told you, you are going to design a product. Now we are going to focus on process only, but I will tell you how this process is getting birth from the design. So once you understand this, automatically the process of Fmea will be very, very simple. First of all, what is this product? What we are going to expect out of this product? So for that, you need to plan with the product name, which customer you are going to work for, what the customer is expecting out of it, the part number, etc., etc. That has to be planned here. Then comes the structure analysis. In structure analysis, structure means what? There is a building structure. In the building, you have kitchen, hall, bedroom, puja room, and whatnot. Okay, this is the structure of one building. Similarly, when you prepare a product, in process of Fmea, a product completely comes out from a production line. It travels some 10 to 20 process step. It travels some 10 to 20 process step. First, it enters as a raw material. It enters into process step 1. From there, it run through around step 10 or step 25. Ultimately, it is coming out of the line. Whatever is coming out of the line, which you are going to sell, that is called process item. That is called process item. That is, it is the output of the multiple step. It is called process item. And each process step, it traveled, like it enters a cutting section, milling section, machining section, then assembly section. Each process step, whatever I named, no, that is called process step or process element. Process step or process element. Each process step has minimum 4 M's to operate. Each process step will have material, machine, method, and what not. Machine is there, method is there, material is there, man is there. Okay, minimum 4. You can add etc. In one of the things is you can add environment, you can add measurement itself. Okay, all these 4M is called a process work element. The output is process item. Output is process item. Each process step is called a process element. Each process element is being made by process for work element. Okay, first of all, we need to understand the structure. The idea of understanding the structure is what are all the things responsible for making the product. So each step, when I go in detail, no, you will be able to understand. Now I am creating a background for this. You need not break your head much here. Just try to understand what I am trying to tell. Then when I go to the each step, explaining the each step, you will be able to understand. Then we are coming to function analysis. When you said process item, say for example, there is a pen, I said. Okay, pen. What is the function of the pen? It has to write. Process item is pen. The function of the item is writing. That is function. For this pen to manufacture, no, there will be each and every step. The barrel, no, one barrel will be there. That barrel will be manufactured by some machine. Okay, a process step will be there. Let us assume there is one cutting process. There is a long tube has come. The tube has been cut. So there is a cutting process. One process is cutting. This process step cutting is one of the process process element. Okay, process element. Now for cutting this particular thing, there will be some machine will be used. A person will be used. A machine is one work element. A person is also an work element. The environment or the material, whatever you are using, no, that is also one work element. In this material, you need to understand raw material is considered to be okay, but you more than the raw material, the consumables, whatever you are using, no. For example, in the cutting section, you may be using lubricant oil. That lubricant oil quality is important. the pH value of the lubricant oil quality is important. So you have to, in the structural analysis, the lubricant oil you have to take rather than the material of the component itself. That kind of consumable, whatever the consumable you are using, that quality is responsible for making this process to turn into a good product. So function of the work element. So you got the pen function is writing. Then there is a barrel was there. Barrel has to be cut. Process element cutting is one process. Then each and every process is being done by one machine or man minimum. The man is a process work element and the machine is process work element. So machine has to cut in such a way that there is no burr. It has to cut. Man has to follow the SOP. This is the function of the functional analysis. The negative of whatever the function you said, that is all failure analysis. Failure analysis is very, very simple. What should happen if that doesn't happen is a failure. What should not happen if that is happening is a failure. Understand? You are putting the ignition key, the car has to start and run. If the car is not starting and running, it's a problem. The car is running now, I am applying the brake, it has to stop now. When it is not stopping, it is a failure. Very simple. What should happen if it is not happening is a failure. What should not happen if that is happening is a failure. So first of all, you need to understand these two things. Then, if at all a failure happens, what is the risk? Okay, fine. A failure has happened. What is the risk? Okay, that severity we have to address. What is the occurrence level we have to address? Then in the optimization case, for all the risk, you will have the action plan. How you will address this risk to minimize this risk? That is the optimization. Optimization is a word neatly coined. See, we cannot avoid the risk totally. We cannot avoid the risk totally. We can have a mitigation plan for that. Okay, so that is the reason optimization is a via media term. It is not totally avoided or it is not totally not taken action. It is a via media. It is in between. How you will optimize, and we have to start learning to work along with this corona. Corona will be coexisting with us. So how you will work along with this corona? What will be your optimization plan? You cannot totally sit idle. So whenever go out, you need to go out, wear the face mask, apply, have social distance, unnecessarily don't touch anything. Likewise, you have to take some optimization plan, then you have to work. Then at last, the result documentation area, we will say, once this project is over, what are all the risks you have encountered? For all those risks, what you have done as a mitigation plan, that you have to tell. Okay, now I will pause for a second. If you have any doubt, now only with this I am going to elaborate. In between now, if you have any doubt, you can just pose me questions.
Mr. RAMAVALLABHAN, we have around 40 participants.
Okay.
And everybody is listening very quietly to you. But you have completed around 45 minutes. And now for the main function, you have only 15 minutes.
Yeah,
then the
will,
question.
you just it will run through, not an issue. Yeah.
Okay. Anybody is having any question? We can take one question here. No question.
Hello.
Can you hear me? Please tell your name and. Hello.
Yeah, tell me.
Ashok ji.
हाँ बोलिए. हाँ.
Because of past year time, I think we should carry on, and then the end we'll have the questions. Better.
Okay, that's okay.
Fine, thank you.
Please.
Hello. Hello. Can you hear me?
Yeah, tell me.
Yeah, Mr. Kannan here, RAMAVALLABHAN.
Yeah, tell me.
I'm sorry, I came in late because I had another meeting going on.
Okay.
I have two questions. I was thinking about it. One is, how do you fit in the PDCA cycle along with your project cycle? That is number one question. You can answer me later also, no issues.
Okay.
PDCA cycle, how do you fit it into your project planning cycle?
Okay.
Okay. Number one question. Number two question is that, you know, we after doing the failure analysis also, there are certain things that you cannot decipher in the whole process, because you compare the Chinese product, you know, you bring it from the shop and
Okay.
it is working in the shop, and then you bring it home, it doesn't work.
Okay.
So how do you define the what is called as the product life cycle, that the product will work only for 3 months or 4 months or only once or twice? How do you kind of fit in that particular thing into your system?
Okay.
I just want to know. I'm not saying I want to fit it in, but how does it happen that, you know, people fit it in so perfectly, even after doing everything so correctly, things don't work?
Okay.
These are two questions I have. If you want to answer it now, you can answer it now, or after you finish also, you can answer. No issue.
I'll try to fit your answer in my delivery now.
Okay, good. Thank you. Yeah.
Okay, thank you.
Okay, go ahead.
Okay, here the project plan, it is on a PDCA cycle only. This project plan, whatever we are starting, it is starting from actually the PDCA. Here you can use the Gantt chart where, first you have to start with the intent. Here is where it is starting. This is the first step. Out of 7 steps, this is the first step. In the first step, what is the intent of the FMEA objective? And other one is what is the timing plan? What is to be done? Which one should be started at the first? At what time? What should happen? At what time assembly should take place? Where are all the area verification and validation has to be done? How the product has to be tested? How the product has to be tested? And finally, how it has to be validated and passed on to the customer. And even the final validation will take place at the customer end. So for all these things, you should have a project plan here. This there I was telling you. If I go to this slide, here is there we are project header here. Here the company name, for which company you are working for, your company name. It's a geographical location, and so with the example I can tell you. So whatever is written here, for that the example is given here. This is the what should be available there. This is the example. For example, company name, it is your company name, JVR Automotive. Location is Chennai. You are working for the customer Swaraj Auto Parts. Model or year you can write to 2020 electrical motor. Subject, this is a electrical motor assembly. When the project has started, on 27th it is started. The next revision has taken place on 14th December. And the cross-functional team. Here is where, you can have the team list, the team members I told. I have seen many FMEA where, there will be a lot of team members will be written in that. In some team member, they will not be available in the organization itself. After he had left, even if he is left, the date is before he left is still it is accepted. The person would have left, after that some revision would have been taken place, still the person name will be reflecting in that. Hope you people will be understanding. They don't give significance of the information whatever they are giving. The person would have been already left, he might not been available there, he might not have even participated in that, but his name will be reflecting there. Now in this case, if you make a separate sheet wherein you brought in a lot of the process wise different people are brought in, and who has to do what, the tool room person, maintenance person, production person, list them, their responsibility you list them, that document you give a document number for that, you list their that document number in the cross functional team here. Then the FMEA number, responsibility, who is the process responsible for this particular FMEA, some XYZ person. And here, they have given 3 different things. One is business use, proprietary or confidential. See, just because in the name of customer, the customer cannot ask you a lot of your intellectual this thing. If you find that there are certain proprietary things are there, you can still say that it is proprietary. They can verify at your place. So likewise, three things are given. One is business use, otherwise you can put confidential and give them. So likewise you can mention here. Then we are moving to the structure analysis. If you come to the structure analysis, see, I'm not skipping the slide actually. This one I will be explaining with the format. Already I have given the summary of it. Now I am coming to the format now. So here you have to start with the process flow diagram. These are all the symbols you can you have to use. So what are the process step? Process step 10, 20, 30 likewise. So this process step wise we have to understand. As I told you, this is the process item. The product whatever is coming out. This is the product which is coming out of our product line. This is process product item. This product item is done by some sequence of process step. This is one process step, this is one process step, this is one process step, this is one process step. So each process step is called a process element. Each process element has operator. As I was telling you, this is a grease device, a greasing device. It is a device which is used for applying grease. You will find here we are not using the material, raw material. Raw material you have to assume that it is coming as okay. We are not doing FMEA on raw material. Raw material the supplier has to do, the whole supply chain has to do this FMEA. So you have to take the FMEA of your supplier also if you wanted to extend your this thing. So here what decides this process step? See what decides this process step? This is deciding the process step. What decides this process item? The process steps are deciding. So this one we are calling as highest level. This one we are calling as lowest level. So now we are coming to the structure. In the structure what we are telling, this is the process item. This is the highest level. Electrical motor assembly is the process item. The 30th process step is sintered bearing press-in process, which is nothing but there is a sintered bearing. Sintering is a process where the metal will be in the form of, for the people who may not be knowing, I'm just explaining. The metal will be in the form of powder. It will be compressed with certain conditions. By that, that bearing will be made so that bearing and all we may not able to properly machining and other things. So there is a bearing which is sintered bearing. That is press-in process. That is the process step. This is in work element. You have operator. You have machine. Now we are in this stage. We are understanding what are all the things responsible for making a product good or bad. It is something like if some crime happens, what is the context? What is the scenario there? Who are all the people available there? Which location? Which came first? Who came first? Who went last? Those scenario we are tracking, right? Similarly, in structure analysis, what is the item? What are all the process step decides that item? What are all the elements which decide the process step? So we are taking things into the consideration. That the consideration step is the structure analysis. Now each column has its own function. Now you are moving to the function. Function should be in the form of verb and noun. What is a verb and noun? Pressing is a verb. Okay. जो करना है ना, सयर्द, सयल, जो करना है उसको बोलते हैं verb. और bearing is a noun, name. Pole housing is a name. When you are describing a function, press-in sintered bearing to pole housing. This is the function. When you understand the function in the structured form, this is the focus element. The center one is the focus element. What is this? Sintered bearing press-in process. What does it do? By doing this, sintered bearing press-in process. By doing this, what it do? This particular thing, how it is carried out. Operator has to press it till it goes and reach to one place. Machine has to press it till its destination point. That is what is described here. By doing this, the assembly, the electric motor assembly, it will be structured properly So that this electrical motor is nothing but it comes for the in the car, the door window riser and lowering motor. If this motor assembly, the sintered bearing, suppose you assume it is going in a tilted manner and it is not going to the end, to the location, designed location, this rising and lowering will not function properly. So what does it do? By doing this process, your comfortability of raising the window and lowering the window will be easier. That is the function of this. And how this is carried out by operator and machine. Now putting that into the tabulation, here in your plant, what is its function? In your plant, assembly of shaft into pole housing assembly. In your plant, that is your organization. You are shifting your this product to the customer place. Shift to plant. For him, no assembly of motor into the vehicle door. He is going to assemble in the vehicle door. What is the end user is going to do? Window rising and lowering. So you need to imagine who is the user, who is the end user going to use it. You need to perceive his comfortability. Based on that only you have to work on the process. Then function of the process. What is the function of the process? Press in sintered bearing to achieve axial position in pole housing to maximum gap per print, which is nothing but there is a pole housing, there is a bearing. The print here it means there is a pole housing, there is a bearing. The bearing and the pole housing should have a exact matching fit. It should happen. It should not stuck up anywhere. Likewise, it has to go and get positioned. And from the machine side, what it does? Machine press in the sintered bearing into the bearing seat in pole housing until the defined axial position. So what the machine has to do? Machine has to press till the bearing goes and sits into its designated position. Now we are understanding the function. Now as I told you, from the function we are going to move on to the failure. In failure, here effect first, effect comes first. You need to understand the failure. Suppose you get fever, first you see the effect. The body temperature goes high, body pain, sometimes vomiting, tiredness. These are all the effect. Then how it happened? This is because of failure mode. Your thermostatic control didn't work, malfunctioning. The thermostatic control, like you have a part called a cerebellum. That is the one which is controlling your body temperature. If it is a hot temperature, your body sweats. In the cold season, you urinate and the salts are removed. Whenever more water is extracted, you feel thirst, you take water. This balancing will take place, your body will be in condition. And so at times you go out and you take some food poisoning take place. Now what happens? Your thermostatic controls get worse. It is malfunctioning now. Now you are seeing the effect first. What you experienced, what is experienced is the effect. Then how it happened? It because of your thermostatic control loss. Why it got lost? Because of some food poisoning. Now failure effect first, failure mode second, then failure cause. So this is what we are going to address here. So on failure effect your plant, this one we are going to see in the sorry, I'm sorry. In failure effect, I just wanted to give you some example. Unable to assemble an operation, unable to attach a customer facility, unable to connect some customer facility, cannot bore at operation. Boring operation may not be happened. These are all the failure effect. Another kind of effect are noise is an effect. Sometimes people may be, even today I saw on Fmea, noise due to, you should not write in the effect. Noise due to should not come. Due to whatever you see, that has to go to your failure mode that from there it will go to the cause. Failure mode is what? Your thermostatic control out. How it happened? Because of food poisoning. Likewise, you have to relate it. So noise due to means it will go to mode or failure cause. So you have to tell the only the effect: noise, high effort, unpleasant odor, intermittent operation, water leak, rough idle. Likewise, failure mode will be what? Loss of process or function. This process function has failed, because of which something got struck. There is a partial function, incomplete operation. These are all the examples of failure mode. Degradation. These are all the examples of failure mode. Here is hollow, too shallow, dirty surface. These are all kind of failure mode. Failure cause. Man, so he might have used some wrong part. He might have not focused to which part has to be applied. He might have loaded incorrectly. Something he would have damaged while picking up. Some wrong material he might have used. From the machine side, some automated control got interrupted. Somebody, they will, from the auto mode, they will use some manual mode and do some fiddling into that. They would have introduced some error. Input data may be incorrectly fed. Some automatic control was bypassed. That is what I have already told. In material, some wrong material has been used. As I told you, the coolant oil, the pH value might not have been correct. Environment. In lighting environment, lighting should be better to have better visibility. The dust, for certain things, dust is sensitive. Dust should not be there. These things. So now, as we saw that function, similarly on the focus element, what will go wrong and what happens? Here, in what happens, if you see, that is clearance too small to assemble the shaft. There, the clearance was too small. The assembly has not taking place. Here, no, axial position of the sintered bearing is not achieved. It's not matched. Axial position is not matched. Here, machine, no, it has stopped even before the destination arrived. Now, this we are putting into the format. In your plant, clearance too small to assemble the shaft without potential damage. You are not able to assemble it at all. That is the main key here. Assembly of motor or vehicle door for the plant, in your customer place, he is not able to assemble it properly. And at the end user place, he is struggling to lift up and down. The window riser, he is struggling. Here the failure mode is axial position of sintered bearing is not reached. Your machine stopped before reaching the final position. So here if you take from structure analysis, function analysis and the failure analysis, the higher level, this higher level to this, from this structure process item, there is a function. From process function, if this is not working, it lead to a failure. And here it's the process step element, focus element. Okay, it has a function, and if it is not working, it will lead to a failure. And this one, process work element. Okay, it has a function. If it is not working, it will lead to a failure. That's how it has to be understood. Then we are moving to the risk assessment. So here the purpose is, if at all a failure occurred, what kind of risk it would have happened. Here the objective is we will assign the rating. We will prioritize. Based on the prioritization, we will be working on that. So on the controls, the prevention control, you can think of some prevention control. There are two things. One is a detection control, other is prevention control. Detection control, you see something, you take some action. Like for example, if a green LED glows, you take some action. If some red LED glows, you take some action. In prevention control, you would have already kept something. Say for example, two-handed operation. Two-handed operation. When two hands are used, one hand is not going to be free, so that he cannot insert inside, he cannot do some mistake. Two-handed operation. subsequent part cannot be attached. That is a mistake proofing. Form dependent functions. Yeah, there is the object itself is like that. It is dissimilar. You cannot reverse it and put it in that position. Then equipment maintenance. By maintaining the equipment, you can do correct. Operator maintenance is required training and regular this thing, regular retraining. Then machine control. First part release. People will be aware of first half, last half inspection. That is one. So likewise, in detection control, you have visual inspection, optical inspection, dimensional check, random check, like that. So here is where we are moving to the scale. If you see, here we see in the risk analysis itself, we saw the severity level. Here on the force adjustment, on the current prevention control, there is a failure. That is, your centered bearing is not reaching that particular point. For that, you are having a prevention mechanism. That is force adjustment according to data sheet. You have a data sheet. In that data sheet, some values are given. Based on that, you are setting. This rating, I will show you the scale. This rating and all we need not memorize actually. I will tell you some logic. Based on that logic, you can understand which particular number you have to take. Anyway, you know, whenever you are doing this FMEA, you need to refer the manual, or you need to refer this reference tables. So these reference tables and all you need not memorize. But one thing I can tell you, on seeing the document, you can have a fair idea. It has to be 8 or 7. How come these people have given 5 or 6 or 4? For which I can tell you certain logic. By understanding the logic, you can get into this. Then on the detection side, current detection and accuracy. Yeah.
Excuse me.
Yeah.
Now we are already covered more than 1 hour, but it's more than 1 hour 10 minutes. So
Okay.
we have to close by 8. So you have 20 minutes. You divide between question and answer. No, there will be some question answer. Yeah. Okay. Just for your information.
You give me some 10 minutes. Last 10 minutes we can answer the questions.
Okay.
Within 10 minutes this will be completed.
Okay.
Already I have reached this point. Next until 6 and 7 will not take much time. Then I will introduce some tables. That's all. That needs 5 to 10 minutes maximum.
Okay.
Okay.
Yeah.
So next is occurrence table. In occurrence for that is current prevention control. What is the current prevention control is that based on that this occurrence table occurrence numbers are taken from the table. Likewise for the detection also, if you have 100% check of motor performance curve accordingly, you can have detection numbers. How these numbers are taken, that also I can show you. This is the action priority. In action priority, what they have made, as I was telling you earlier, RPN was there, severity into occurrence into detection. You have straight away multiplied and told it has a risk priority number. In action priority, what they have done, they have made a table with all the configuration, with all the combinations of severity, occurrence, detection. If severity is this number, occurrence is this number, detection is this number, then you say it is H, high, moderate or low, HML. That's what they give. Then special characteristics, say for example, in every product there should be some special characteristics. Once again, I take the pen example. You have the pen, there is a barrel and you have a cap. Pen's barrel OD is significant characteristics. The cap ID is significant characteristics, right? Then only it will have a proper press fit. So wherever the interface is taking place, that will be the significant special characteristics which we need to derive or get it from the customer. The filter code is the one you can say it is whether it is you can have a code by which you can relate it to the action priority. It is optional. It is given as optional. If you want, you can have. Otherwise, with this you can operate. Then collaboration between the customer and supplier. You will based on the output, you will talk to the customers. Optimization is the thing. Now you have completed the FMEA. Now you have to take some action plan. FMEA is a continuous cycle actually. It is a live document, means you have to continuously work on that. So in order to improve your severity, occurrence and reduction level, you will identify certain projects based on the action priority. You will make some assignments of responsibility of personnel with the team, they will work. Once you do that work, you can you have some status of action. You have to have a clear-cut status saying that yes, this project is going on open, or it is decision pending. That is, the project is over, we have worked out, we have not come to a conclusion, probably we may require more data or something like that, the decision is pending. Sometime implementation is pending. The project is over, once again the product has not come, that is the line is not running now, because of which we may not able to implement. Once the product once again starts now, that time we will introduce whatever the actions we have taken. The other one is completed. Yes, things are over, we have completed it. Last one is not completed, which is it can be not completed or discarded. It has not worked out properly, that is why we have discarded it, hence it is not completed. So here is where once the things are over, we are proposing the action. These are all the proposed action. What are all the preventive action you are going to do? You may be working on some mistake proofing, or you may tighten your detection mechanism by which your prevention can improve. And who will be detection action? What is the detection action you have taken? Who is responsible for that? What is the target date? And what is the status now? As I was telling you, it is open or decision pending or completed or not completed, what not. Then what is the finally what is the action taken with the point of evidence? What is the final action taken with the point of evidence? Then completion date. Now the current severity occurrence detection. The earlier one would have been more. Now it has to be reduced. Earlier it was medium. Now it has come to L. So with this we are completing the actual project. Finally, we are coming to the result documentation. Here is where this time nicely this result documentation is left to us. What the management will be interested with, that one you have to project to the management. You need not talk about the severity, occurrence, reduction, etc., etc. This is the project we have done. Earlier the rejection level was like this. Earlier the failure level was this. With this, we were incurring this much cost. Now by doing this project, the cost has been reduced to this much. Our incurring of some resource cost was this much. Now our estimated saving will be this much per day, per week, per month, per year. Likewise, you have to project it to the management. Then for all the people, what are all the risks involved in the process, where you need to take care, those things you have to tell. With this, this 7-step approach is completed. Here I have just made the summary. If you see, this is the first thing what we have seen, the process step 1, the numbering and other, that is the scope of the project. Then we saw the structure analysis, the process item, process element and process work element, and each process item has some function, process step has some function, process work element has function. The negative of process function is failure. This is what the failure, the severity, the failure mode and the failure cause is there. Then finally we are coming to the risk analysis. If at all failure happens, what is the prevention mechanism we have? What is the detection mechanism we have? What is the relevant to the table? How it has to be addressed. Then the optimization comes. the result documentation comes. Here I wanted to stop the share here. I wanted to go for new share. Just 1 second to go for new share. See, this is the table actually. 1 second. You can just understand the logic. I will just run through. It is not, you need not worry to how you give the severity number. Here in the process, if there is a safety issue for a person whoever is working in the process, if there is a safety issue, it is 10. It is 10. If there is a statutory and regulatory requirements, if there is a norms violation, a process should not have this much pollution, what you call pollution level should not be there like that, or in the process when the people are working, no, some safety mechanism should be working. If some safety regulatory things are not working and still the process is on, you cannot be sure that an accident may take place. Okay, if that is the case, if some regulatory things are not in place properly, then it is 9. Then coming to the product, if you are manufacturing, your process is on, if some 100% of the product is going to be scrapped, it is 8. When the process output is going to be scrapped for 100%, it is 8. If some 100%, if some partially, if not 100%, partially if the product has to be scrapped, it is 7. If 100% of the product has to be reworked offline, the process has been made, it has come out with a lot of burr. Directly it cannot put into the process. Somebody else is need to rework it and pump into the line. Then it is 6. If some partially, some are okay, they can be taken into the line directly. Some need to be reworked offline. It is 5. 100% of the product need to be reworked inline. There is a process, you are giving a file to him, he will be rubbing it slightly and then he will put. Then it will be 4. Partially he need to do it. Some are having some problem. For those things only, the inline operator is going to do that. Then it is 3. See, your cycle time is getting lost in this. Then it is 3. Some disturbance, that is the part was purchased long ago. It was in store. It is having some lot of dust. You give him a cloth and you are wiping it out and putting it in the process. A slight disturbance, it is true. No discernible effect, means nothing more serious, nothing in that. It is almost nil. You cannot give 0, you are giving 1. Okay. So here you understand the logic. I have not read anything here. I'm just reading the logic. Safety, total operator safety 10. Regulatory thing is violated 9. 100% of the product is getting rejected 8. Some portion is getting rejected, scrapped. It is 7. 100% need to be reworked offline 6. Partially reworked in the offline 5. 100% reworked in the line 4. Partially reworked in the line 3. No discernible, some disturbance 2. No discernible effect 1. That's all. Likewise, if you take the occurrence table also, the prevention based on certain prevention control. Occurrence table based on certain prevention control. No, it is extremely high. There are 3 tables available. I will just go through one. No prevention control, it is 10. Prevention control is there. It is not all having little effect, 9 or 8. Prevention control is there, somewhat effective, 7 or 6. Likewise, if you refer to this table, the prevention control is highly effective. It is coming down 3, 2 like that. So you need not memorize it. If you just run through this table for once, you will try to you can understand that. Similarly, on the occurrence, this is on occurrence itself. You have 3 tables, multiple times or frequency wise like that. On the detection table, failure mode cannot be tested at all. It is 10. On random basis you can test, it is 9. By doing some visual inspection, you can test, it is 8. By doing some digital control, some automatic control, it will come to 7. And you have certain mistake proofing mechanism wherein, you know, the next level operation will be detecting it. Then 4. In that particular position, once it manufactured, it will not allow to do the next operation. 3. That stage itself, you cannot assemble as a wrong product. Then it is 2. Totally a mistake proofing mechanism is kept. It is 1. Likewise, it is given. Coming to the AP table, here is the combination. You can see the combination.
Sir,
completed.
Sir, we can take the question answer.
Okay, completed, sir. This is the AP table wherein you will see the configuration. If it is 9 and 10, if it is 9 and 10, if it is 7, 10, 5, 6, it will be H like that. So you can have this, this manual is available for some cost. Earlier it was 20,000 or so. Now the price would have been reduced. It can be purchased. It is all available there. Whoever really wanted to implement that, you can apply this manual. With that, you can learn the subject. So fairly, I've completed the walk through the complete 7 step. Now I'm ready to take the questions.
You can stop the sharing and we can take question. So
stop the sharing. You will take over, na?
Sharing you can now stop. I feel.
No, yeah, I'm stopping the share. I've stopped.
Okay, now we can see only you. So if anybody has a question, he can just tell his name, the company, and ask the question. And you can show your video also if you want to ask direct one-to-one. So Mr. Vignesh is there. Vignesh wants question.
Sir, I need some question to be clarified.
Okay.
Actually, they have given rating on what basis they have given that rating, that is M, L, etc. for action priority.
Yeah. See, if you critically examine that action priority, severity versus occurrence versus detection. If it is, say for example, severity is 8 or 9 and occurrence is 6 or 7 and detection is 3 or 1, it should be H or M or L. When you critically examine that action priority, you will find the vulnerability of the product. See, this can be well explained when there is a physical example of your product or process. In that process, taking that and matching to that particular thing, you know, we may able to explain it clearly. They have done lot of research work. You will not believe. From 2016 to 2019, AIAG is Automotive Industry Action Group. VDA is Webernet D Automobile German. These US people and German people jointly sat together for 3 years. Since 2016, they jointly worked. On June 3rd, 2019, they released this. Okay. Then I have taken around 1.5 months to understand this, and I have attended certain webinar of the person who has created this document. One Mr. Scott Gray and one more person was the project head for this particular project. So with them I have understood thing, and I have taken a program directly from AIG Plexus people. Okay, and for your question, special case if we take on that, if I explain, I can explain this. Then any other question?
Yes, anybody else? Any question?
See, I have one question, Mr. Kannan here.
Yeah.
My question is, you know, in the current situation, a lot of people have outsourced their manufacturing operations, even in most of the components. and they are only doing the assembly of the final component and selling.
Yeah.
Now, in a situation like this, how effective is this FMEA going to be in terms of cost of poor quality assessment, number one, and how is it going to be able to address the voice of the customer? These two are very, very important concerns I have.
Yeah, fantastic. As per IATF 16949,
Hello.
2006. Yeah, your question is complete. I can start.
Yes, yes.
Yeah, as per IATF 16949 2016 standard, this is one of the core tool applied for that particular standard. In that standard, there is a class, IATF 16949, there is a class called Supplier Quality Management System Development. In section 8.4, you have a class called